All right, hello again, Algebra 2 people. So yesterday in class, we had a discussion for a while about what imaginary numbers are, what complex numbers are, and kind of, a discussion about dimensions and stuff like that. And just to recap that, remember, a complex number is nothing more than a combination of real numbers, which we've known for our whole lives, and these new imaginary numbers. And we can graph on a complex plane, and I'm not too worried about doing that right now. But just, as we go into today, know that a complex number is just a real number plus an imaginary number. We call that format A plus BI. Okay? And then we talked about, well, okay, what is this I thing? And we define I as the square root of -1. So, and we talked about, if you have the square root of -25, we can rewrite that as 25 minus 1. So we can write that as just plus or minus 5i. If it ends up being a not clean square root, we can still take the negative out. And like, for instance, the square root of -5 could just be written as plus or minus I times root 5. Okay, so that leads us into like the actual formal notes. So I'm not going to write down every single one of these, but we know that like back in the day, you would say root 49 is 7, 144 12, 1 is just plus minus 1. And before today, we couldn't do the negative square roots, but now we can, right? So now if we have negative root 49, we know that's plus or minus 7i. Root negative 144, that's plus or minus 12i. Plus or minus root 4, plus or minus 2i. Okay? And even ones, like I said a second ago, even ones that you can't simplify, like root 13, I can just write that as I times root 13. So it'll be plus or minus in front of there. 8, again, plus or minus I root 8. Depending on your teacher, they may want you to simplify root 8. So this could also be written as I 2 root 2, or 2I root 2. But of course, 121 is square root of 11, so that one would be plus or minus 11i. Okay, so just using the definition, anytime we have a square root of a negative number, we can have it as I times the square root of the positive number, and then simplify or clean that up if we can. Okay, but the main part of this video is going to be doing operations. So we're going to start off with adding and subtracting complex numbers. This is super straightforward. All it is, just like you see highlighted right there, all you got to do is just combine like terms, which you've been doing for years now. Right? Combine like terms and just watch your signs as you always do. So if you look at the first example, 3 plus 2i plus 7 minus 5i, I can do 3 plus 7, which is 10. And then I can do 2 plus or minus 5i, which is negative 3i. And that's your answer. You're done. Okay? If I skip down to the third example with a subtraction, the main thing to remember about this is that minus sign distributes, right? So again, when I combine like terms, 11 minus 11 is 0, and then 3i minus a negative 3i is positive 6i. Okay, and by all means, you could write that as just 6i and not worry about writing the 0 down. So what I'm going to ask you to do right now is pause the video for just a couple seconds and go ahead and do that second example and the fourth example, and then I will move on in just a minute, show what those answers are, and then move on to multiplying and dividing. Okay, so hopefully you've gotten those two answers on the first one. With the adding the two complex numbers, that should end up being negative 1 plus 2i. And then the last one, subtracting, again, remember that minus sign is distributing. So that's going to end up being 7 plus 3i. Okay. Let's move on to multiplication. Before we get all the way to multiplication, we got to figure out, because obviously if we multiply two things with I in them, we're going to get powers of I, right? The main one we got to talk about is I squared. Okay? So we take I times I, or I squared. What does that really mean? Well, it means we have the square root of -1 squared. And we know that if we have a square and square root, they just cancel each other out. So I squared is equal to -1, which is kind of interesting if you think about it. Okay? So an example of that would be like if you did 2I times 3I. Well, again, it's multiplying, so we're still going to take 2 times 3. So that would be 6I squared. But again, I squared is -1. So the upshot of this is anytime you see an I squared, we're just going to replace it with -1. So that's 6 times -1, which is -6. Okay. Similarly, if it ends up being a negative, let's say we have 4I times -5I. Now, again, multiply the coefficients, so it's -20I squared. But again, replace the I squared with a -1, so that would be -20 times -1, which would just be +20. Okay? Flip the sign, basically. So when you get an I squared term, just flip the sign, because that's all it's going to happen, because you're multiplying it by -1. Now, in the interest of keeping the video a little bit shorter, I'm not going to talk about the higher powers of I. If you're curious about what happens there, you can talk to me or talk to the teacher that you have, and I'm sure they'll be happy to talk about the higher powers. It is an interesting pattern, and there's a definite pattern that happens, but I want to go ahead and move on. So let's go ahead and do the application of this. So we know how to multiply things together too. Again, you've been doing this for years, either distributive property or FOIL, box method, stuff like that. But we just have to watch out when an I squared term kind of pops up. So on the first example though, if I just distribute that 3, I just have 12 plus 9I, no powers, nothing else going on, so that's it. That's your final answer. But on the second example, now if I distribute, I got 10I, and then I have plus 20I squared. And again, this is what you got to remember. If you leave that as your answer, we're not going to give you full credit for that. I don't care who your teacher is, because we want to simplify that I squared term, because we know what that is. So we know I squared is -1, so really this is 10I plus 20 times -1. And so that would be 10I minus 20. Now, that's okay. I'm not going to get picky about that, but we should write that as -20 plus 10I, so that our answer is still written in that same complex number format. Okay? Next example, same exact thing. So we got 2I times -3, 2I times -I. So remember that -2I squared is -2 times -1, which is +2. So -6I plus 2, or again, should write that as 2 minus 6I. Okay. Now, the next three are, and again, you've been doing this since your algebra days, are like either using FOIL or the box method. I don't care which one you do. I'm sure your teacher doesn't care which one you do. Whichever you're more comfortable with. I'm going to do the first example with FOIL. With the box method. And then I'll do the second one with FOIL. So if I do 3 plus 2I and 1 plus 4I, remember, in each box we're multiplying, so 1 times 3, 1 times 2I, 4I times 3, 4i times 2i. Okay? But now, if I just write that out, I can combine some like terms and then simplify the I term. So I got 3 plus 2i plus 12i plus 8i squared. And remember, these two guys right here, 2i plus 12i, those are like terms, so I can just combine those. And this, remember this, is equal to negative 8. So really what I have, I got 3 plus 14i minus 8. But I can now, because I can just add 3 and the negative 8, so my final answer is negative 5 plus 14i. Okay? So again, I'm going to ask you to pause the video, go ahead and do those last two examples. And again, if you're a FOIL person, you know how to do FOIL. And see if you can get those answers. And again, I'll pause for about 5 seconds myself so you can pause the video, and I'll just write down the final answers. Okay, hopefully you got those. So when you do FOIL or box method, either one, what you end up with on this one is 15 minus 10i minus 3i plus 2i squared. And then when you combine like terms, so just like on that previous one, we got that's negative 13i, and this is minus 2. So we're going to end up with 13. 15 minus 2, 13. Negative 10 minus 3i minus 13i. And then the same one on the last one. So the last one we have 32 plus 20i minus 24i minus 15i squared. Combine those guys. Simplify that to positive 15. So 32 plus 15 is 47. 20i minus 24i minus 4i. Okay, so that's multiplying. Last one we got to talk about is dividing. Well, dividing, we're actually going to turn it into a multiplying question, as a matter of fact. But before we do that, we got to talk about something called the conjugate. And if you see on this top highlighted line here, the conjugate of a complex number, if you start with a plus bi, all you do for the conjugate is you switch the sign of the imaginary part. Okay? So what does that mean in practice? So if you have the conjugate, if you want the conjugate of 4 plus 3i, that's just going to be 4 minus 3i. You leave the real number part alone. You don't do anything with it at all. You just flip the sign of the imaginary part. So conjugate of negative 3 minus I would be negative 3 plus I. The conjugate of 5 minus 2i would be 5 plus 2i. And that's all that a conjugate is. We'll talk more about conjugates in a later video when you go back into the solutions of quadratics and higher order polynomials. But that's how you find the conjugate of if you're given a complex number. So what we do is when we have a division question like the next example, is we will multiply the top and the bottom of the fraction, both sides, by the conjugate of the denominator. So here's my problem. So what I do to perform the division process, it is a multiplication question. So the conjugate of the bottom, 1 minus 4i, is 1 plus 4i. And you multiply that on the top and the bottom. And then, again, FOIL, box method, whatever you want. So I'm gonna knock those out pretty quickly. So we got 3 plus 12i plus 2i plus 8i squared on top. On the bottom, we have 1 plus 4i minus 4i minus 16i squared. Clean up the top. We know how to do that. So 3 minus 8 is negative 5. 12i plus 2i over. Now, the thing on the bottom, here's where the magic happens. Because notice positive 4i and negative 4i, they cancel out. So I just got 1 plus 16. Change the sign. So that's that. And that's essentially your final answer. The only thing I would recommend, that's totally acceptable as a final answer. But if you're but format wise, you'll often see it also written as negative 5 over 17 plus 14 over 17i, so that it's still in that same a plus bi format. Okay, so let's go and do one more example, and I'll let you guys do the last two on your own to practice a little bit. So again, conjugate of the bottom, in this case it would be 2 minus 5i. Now I'm not going to talk while I do this, I'm just going to work out each the top and the bottom. See if you can, and while I do this, see if you can follow along and see if you can see what the numbers are going to be. So that's going to be a negative 11 minus 16i over 30. And again, we can write that as negative 11 over 30 minus 16 over 30i. And even that last piece could be simplified. 16 over 30 divided both by 2. Oops. So you can write that as minus 8 over 15. So go ahead and pause the video for, again, do the last two. Let's see if you can work out the last two completely by yourself. And then I'll zip through those and we'll finish it up. So here we go on example 3. So conjugate would be 7 plus I. So you have 29 plus 11i over 50. We'll do that one. And then last but not least, for this one, again, we still do the conjugate, nothing changes. But notice on top, the top is just distributing. So this is 12i minus 12i squared. Bottom, still fuller box.
So the top is just 12, positive 12 minus plus 12i over, middle term shall cancel, 9 plus 9 is 18. In this case, I can divide all those by 6. So I got 12 and 12 and 12, so I can get a common, a GCF basically. So that would be 2 plus 2i over 3, which again would be 2/3 plus 2/3 i.
So those are all of your operations with complex numbers. If you have any questions, as always, let me know. Put a comment down below or talk to your teacher, send me an email. Until next time, stay safe.